Seasons. What are they? Why do they happen? Why does the temperature change throughout the year? And how does this relate to the last video? Some people might think that the reason the seasons happen is because Earth's orbit isn't a perfect circle, so that when Earth is farther from the sun, it's winter, and when it's closer to the sun, it's summer. While this explanation may seem like it does account for the temperature change, it fails to account for several other phenomena. First, why is it that when it's summer in the northern hemisphere, it's winter in the southern hemisphere, and vice versa? June, for example, is only summer for half of the Earth, while for the other half, it's winter. It may not feel that way because almost 90% of people live in the northern hemisphere. For half of the Earth, Christmas occurs during the summer. Isn't that crazy? Second, why are the days longer in the summer and shorter in the winter? If only distance is a cause of the seasons, why are the days longer during the summer? Third, many might not notice, but why is the sun higher in the sky during the summer and lower in the sky during the winter? Thus, this seasons are caused by distance explanation fails horribly. While it's true that Earth's orbital eccentricity isn't a perfect circle, as all orbits are described by Kepler's second law, it is very close to being a perfect circle, and the different distances are negligible at best, not enough to significantly change the temperature. But that's a story for another time. So what is the cause for the seasons? Why is it warmer in the summer and colder during the winter? Well, the answer is exactly the same as to why it's warmer near the equator and colder near the poles. A shallow angle. The equator isn't warmer because it's closer to the sun. It's warmer because the sun is directly overhead. As you get closer to the poles, the sun's rays come in a shallower angle, meaning more surface to cover for the same amount of rays. That is why it generally gets colder as you move away from the equator. Now we need to talk about Earth's axial tilt. No planet, because space is never perfect, spins exactly in a 90-degree accordance to its orbit. Imagine an imaginary line of rotation, an axis of rotation, going from pole to pole. The spin can't coincide exactly with the angle of the orbit. Earth's axial tilt is roughly, as it happens, to be 23.5 degrees, meaning its axis of rotation is tilted by around 23.5 degrees compared to its orbit. So, when a certain hemisphere is tilted towards the sun, it gets much more of its attention, making it summer. The sun will appear higher in the sky, and as a result, it will be warmer. Because space does not have an up or down, you can imagine the orbit being tilted instead. So in certain parts of the year, as you can see, a different hemisphere is more directed at the sun. This is why the days are longer in the summer as well. When a hemisphere is tilted towards the sun, it will be more exposed to it. The closer you get to the poles, the longer the day length. So, as the direction of Earth's tilt stays roughly the same, there are 4 important moments during the year. The March equinox, the June solstice, the September equinox, and the December solstice, each occurring around the 20th to 23rd of their respective months. This divides the year into roughly 4 equal parts of 3 months length. Between March and September, the northern hemisphere is tilted towards the sun, reaching its climax of 23.5 degrees during the June solstice, the longest day of the year in the north. Northern summer, southern winter. Between September and March, the southern hemisphere is tilted towards the sun, reaching its climax of 23.5 degrees during the December solstice, the longest day of the year in the south. Southern summer, northern winter. The website Time and Date can show us how the day and night map changes during the year: March equinox, June solstice, September equinox, and the December solstice. You can see, for example, how in the June solstice, the sun isn't above the equator anymore. It's much more north. Well, then where exactly is it? Let us think this through. During the June solstice, which occurs around June 21st, the northern hemisphere is at its maximum tilt towards the sun of roughly 23.5 degrees. 23.5 degrees. So the sun is directly overhead, the latitude of 23.5 degrees north? Yes. This latitude is called the Tropic of Cancer. During the December solstice, the sun is directly overhead, the latitude of 23.5 degrees south, the Tropic of Capricorn. So, during the year, the sun is only above the equator during the equinoxes, the March equinox and the September equinox. Anytime else, and it's between the Tropic of Cancer and the Tropic of Capricorn, an area called the tropics. The tropics are the only areas in which the sun can be directly overhead. Therefore, they usually have warmer climates. During the June solstice, when the sun is directly overhead the Tropic of Capricorn, or 23.5 degrees north, anywhere south of 66.5 degrees south, in other words 90 degrees lower, cannot see the sun. No daylight. This latitude is called the Antarctic Circle, while anyone north of latitude 66.5 north, called the Arctic Circle, can see the sun constantly due to the axial tilt. What this means is that during the June solstice, anyone above the Arctic Circle has 24 hours of constant daylight, while anyone below the Antarctic Circle cannot see the sun even during noon. During the December solstice, the other extreme happens. Anyone below the Antarctic Circle has 24 hours of constant daylight, while anyone above the Arctic Circle cannot see the sun even at noon. This is all because the subsolar point, or, in other words, the place on Earth where the sun is directly above it, shifted a whole 23.5 degrees north or south. The subsolar point migrates from north to south throughout the Tropic of Capricorn and the Tropic of Cancer throughout the year. That's the seasons. The short answer as to why it's colder during the winter and warmer during the summer is because of Earth's axial tilt. Or you could say, because the sun is lower and the sun is higher.